Hello, welcome back student to the design and analysis of algorithm class. Before going to today's lecture, we will see what we have done in the previous class. We saw the asymptotic notation, and we saw the basic asymptotic efficiency classes, and we saw the big O, big omega, and big theta. These are the things we have discussed in the previous video. Go and watch the previous video if you did not watch the video. Okay, so today's objective is we are going to see the disjoint set operations, and we are going to see how we will represent the sets, and the third point is union operation, and the last one is find operation. These are the things we are going to see in the today's lecture. So what is disjoint set operation? In the disjoint set, in mathematical, two sets are said to be disjoint if they have no element in the common. Okay, example, like if you have see the example, the two sets, this is called one set and this is called another set. Okay, this one is a one set and this one is a another set. So these two sets are there, and this two should not be equal element, means same element. 1 2 3 here, 4 5 6. In the two sets are different. When you come to here, 1 2 3 and 3 4 5, that means here is 3 and here is also 3. That means the both are common. So this is not a disjoint set operation. Okay, so equivalently, disjoint set are set whose intersection is the empty set. So first is, we can say the both two sets should not be have the same element. Okay, set 1 and set 2 should not have the same element, we can say that. And the next point, we can say whose intersection is empty. When the both are different, then our intersection is empty, so there is disjoint set operation. Okay, I hope you understand. In this two set, this should not be a common element. Okay, that should not be a common element. Here we don't have a common element because 1 2 3 4 5 6, and here 1 2 3 and 3 4 5. So 3 is a common in the both the elements. So this is not a disjoint, this is not a disjoint set. First one is a disjoint set. Okay, fine. So here we will see the simple example here. Sorry. So here, representation of set using tree. How will you represent the tree? How will you represent the set using tree? Suppose we have a S 5 6 7 8 9 10 11 12 13. These are the elements in the set S, and this thing I want to divide it into 3, which is divided into 3 subset, says JKL. Okay, so J is having 5 6 7, K is having 8 9 10, L is having 11 12 13. We divided equally in 3 subset. Okay, this 5 6 7 8 9 10 11 12 13, this is a set. When you are dividing that, this is a subset. Okay, subset of S. J is a subset of S. Okay, how will you represent this in a tree? J is equals to 5 6 7. You can take any one as a root. So I am taking the root 5, 6 is a left node and 7 is a right node. You can take any element as a root. So I am taking the first one. And in the K, 8, 9, 10. In the same way, how I am taking the first element in J as a root, so I am here also I am taking the same thing, 8, 9, 10. So you can take any one as a root, okay, is up to you. 11, 12, 13. So 11 is a root for me, and the left and right is a left node and the right node, okay, and this is root node. So this is representation in tree. So JK, first what we have done, this is S, and this we have divided, set is divided into subset in 3 JKL, and JKL, J is 5, 6, 7, and we are considering 5 as a root node for me for this subset, and here in the K I am taking 8 as a root node for K, and here I am taking 11 as a root node of L. So how will you represent in data structure in array? This set can be represented by considering every element of a set in a same array. So here, whatever the root element in this tree, this is a representation of set using tree, and here we are representing in the array, in the same array. So here we can see the root is 5, 8, 11. So here we are taking 5, 8, 11 as a -1. So -1 is indication is it is a parent node. Okay, this is a parent node. Fine. So here we are representing in one only, one array, and here 5, 6, 7, 8, 9, 10, 11, 12, 13, these all are the elements, and A, B, C, it is a subset, like we have taken JKL, in the same way here A, B, C. So A set has 5, 6, 7, B set has 8, 9, 10, C set has 11, 12, and 13. So here we need to represent the parent. So 5, for the 5 we don't have any one parent, so 5 itself is a root node. So root node will represent as -1, and 6. In here 6, who is a parent of 6 is 5, so just we are writing 5. Here in the K is 7. 7 is right node, means leaf node, and is a parent, so parent is 5. In the same way, in the second, here 8 is a root node, 9, 10 is a leaf node of root 8. So here in the 11th one is a root, 11 element is a root node, 12 and 13 is a leaf node of root 11. Okay, the root node 5, 8, 11 has a parent -1. The kth element shows the tree node which has element k. It also identifies the parent's pointer of representative tree node. Find and union operation can be performed on disjoint set. So our next topic is find and union. Whenever the set is disjoint, at that time we can apply and we can do the operation find and union. Whenever the set is disjoint set, then only we can perform find and union operations. Okay, so in the top, representation of set using tree, and here representation of set using array, we can say. Okay, within the same array we can define. Okay, so now our next disjoint set. disjoint set. Okay, the disjoint set ADT is a data structure that can store information about a group of sets. It support to following operation. So what is ADT? It is store information about the group of sets. First, here some operation is there. First one is a make I. This operation is used to construct the set. Okay, whenever we are constructing the set, at that time it will use, like make 1, then 1 is a set. Make 2, then in the flower bracket you need to write the 2, so that is 2. So this is the example of make. Second one, find. This operation is used to find the name of set to which it belongs. The name returned is the item I, which is at the root of tree. The set are stored as tree. For example, if P has some set and Q is some set, are two disjoint set, because in the both that is different, there is no common element in these two sets, so this is called disjoint set. And I want to find 4, and 4 is present in the queue, so it will find from the given sets and it will give the result. Union is I comma j. This operation takes the takes the name root node of two sets and combine them into one, like union 1 comma 4, then 1 comma 4 in the flower bracket. This is become a set. Whenever we have like union 1 comma 4 or 1 comma 5 10 anything, how many are there, 1 comma 3 4, then we are making it together, that is union. Okay, so this is a disjoint set ADT. What is the use of it? This is store information about the group of set, and 3 important operations we can perform. The first one is make, second one is find, first one is make, second one is find, and third one is union. Third one is union. Okay, next, union operation. First we will see the union operation, then we'll go to the find operation. Union I comma j means the element of set I and element of set j, element of set j, I and j are combined. Just now here we did it union 1 comma 4. What is 1 is I, what is 4 j, so we combine. If we want to represent union operation in the form of a tree, then union I comma j, I is a parent, j is a child, is represent as. So whenever we have a union I comma j, so whatever the I, every time we will make I as a parent and j is a child. Okay, so here ij means union 1 comma 3, so 1 is a parent and 3 is a leaf node. Union 2 comma 5, 2 is a root node, 5 is a leaf node. Okay, let I and j be the root of two disjoint sets. I and j be the root of two disjoint set 1 3. Okay, so this is a union operation in the DAA. So when we will perform the union operation, when we have the disjoint set, when the two disjoint sets are there, that time only we can perform the union operation. We'll see the algorithm now. Union algorithm. Algorithm to union of two disjoint set. First, integer I comma j, like here I comma j, union I comma j. parent is I and j is a leaf node. What we are doing here, that we are writing in the algorithm. End of u is nothing but union. So when we perform this algorithm, okay, when we perform this algorithm, time taken to perform union operation is constant. Therefore all n minus 1 unions can be proceed to time order of n. So whenever we are writing algorithm, whenever we are solving any problem, or in DAA, every time we need to check the time complexity. So what is the time complexity of union algorithm? Is order of n. Okay, we will read order of n. Like we have discussed big O, big omega, big theta, but we cannot define this. Before defining that 3, first we need to say order of n. Which one is the suitable for this? It is a best or worst or average. Based on that we will put here big O, omega, theta. But till now, from now onwards, we used to say is order of n. Order of n. Next, if we take the example, okay, now consider some example of the above parents array 0. We will perform the operation on union. So first of all, in my array nothing I have, 0 0 0 0 0. I have 6, 1 2 3 4 5 6. So union 1 comma 3. 1 comma 3 means union 3, and 1 is a parent. Okay, parent of 3. Who is a parent of 3? Parent of 3 is 1. This is ij. So here parent j is I. Okay, so here, so in place of 3, in place of this 3, we need to write 1. Why we need to write the 1? We are writing 1 because 1 comma 3 means this 1 is a parent of this 3. Okay, this is the first step. And how will be represent in the graph? 1 3, arrow mark should be to the root node. Okay, this is one example. Next, if we have union 2 comma 5, if we have 2 comma 5, so parent 5 means parent j is to be 2, is to be 2. So where the 5, where the fifth element, there we need to write the 2. Why we need to write the 2? The fifth element is a leaf node and the is root node is 2, so it will go here in 2. Okay, so how will be represent as in the graph is 2. Okay, the next one is union 1 comma 2, parent 2, parent of 2 is 1, parent of 2 is 1, 1 comma 2 means. So how will you represent this? In the same way, 1 same like this, and it will be 1 2. Okay, the root of this second one is 1. So we need to go to the root 2, sorry, we need to go to the second element and we need to write the 1. Why we are writing this 1? Because the second node is a leaf node and for this is a root node is 1. Okay, so in this way we will represent as union. So easily we can easily identify, so which one is a leaf node and which one is a root node. So how will you represent this? First 1, okay, 1 is a root node and 2 and 3 is 1 is there. For 3 2 we have 1, so 3 2, and next is fifth one is a 2, so second one is 2 is a root node of 5. So you can draw in this manner. First it was a separate, then we draw in a single tree. Okay, so this is very easy to understand. Okay, next, find operation. In the find operation implies that if it find the root node of ith node, in other word it return the name of set I. Each find operation required following chain of parent links from node 1 to the root node. The time required to perform find operation for an element at level I of a tree is order of I. Therefore, total time needed to proceed in n minus 2 finds is order of n square. What is the time taken for the find algorithm is order of n square. Okay, so what is the algorithm for this? Is integer I comma j, and j is I, the same thing what we have done in the union. Here we are checking while parent j greater than 0, do j is parent of j repeat. At the last return the j and end f. This is if you find difficulty here, we will take one example, then you can easily identify and you can easily understand this concept. While is checking print parent of j is greater than 0. So in this, here it is checking 0. If it is 0 or 1 or something, whatever the things, it is checking. If it is greater than 0, then do this operation, otherwise return the j value. Whatever the value is present in the j, return that. Okay, let's take the example. Here we will take the example, the same example what we have done for the union. So in the union we got the answer 0 1 1 0 2 0. We will take the same array representation to find the element. So first I want to find the element, fifth one I want to find this element first. So I is equals to 5, j is a root node of I, j is equals to 5. Okay, what I want to find, I want to find the 5. So what is the value of value of j? The j is 5 only. Okay, while p of j greater than 0, p of j means p of j is 5. In the 5, p of 5, what is present? Is present is 2. So what is j of p of j? That is j is equals to 2. What is what I have? 2. The condition is true and we got the value whatever it is present in the array. Next, again we need to repeat again as per the algorithm. Again p of 2 greater than 0, p of 2, this is greater than 0. Yes, it has the value 1. Okay, so the condition is true, 1 greater than 0. Yes, this 1 greater than 0. So j is p of 2, that is the value what we are getting, whatever the value is present in the second element is 1. Okay, now while p of 1 greater than 0 means what is the value, is present in the first element is 0. So 0 greater than 0, then the condition false. When the condition false, whatever the value is present in the j, that will display. So what is the value we had in the previous step? In the previous step we had j is equals to 1. So return j. So 1 is root node of node 5. Root node of node 5. Okay, so we can observe same thing for the above figure. So here we mention for node 5, for the node 5 the root node is 2, so it will come back to the second element, and from the second element it will check, yes, for the second is a 1, so 1, then again it will go to the 1 and it will check. If it is 0, then we can say the root node of this phi, root node of this phi is 1. Directly we can say root node of, we can say like this, okay, root node of the phi is 1, we can say like this. So this is about the find algorithm. Okay, so what we have done in today's lecture, we saw the disjoint set operation, and we saw how to represent the set, how to represent the set uh, using tree and array, using tree and array. And we saw the union operation, what is a union operation, and we saw the find operation, union operation, and we saw the find operation. So this is what we have done in the today's lecture. We'll see you in the next lecture. Thank you very much.